Hey everyone! Today we're diving deep into JavaScript closures. By the end of this tutorial, you'll understand what closures are, how they work, and why they're such a powerful concept in JavaScript development. So what exactly is a closure? Let me explain the concept. A closure is a function that has access to its outer function's scope even after the outer function has returned. The key points to remember are: first, closures have access to their outer function's variables; second, they remember the environment in which they were created; and third, they're created every time a function is created. Closures work because of something called the lexical environment. The lexical environment is the environment in which the function was declared. It contains all the variables that were in scope at the time the function was created. The key points are: first, the lexical environment is created when a function is defined; second, it contains all variables in scope at that time; and third, it persists even after the outer function finishes executing. Now let's understand how closures actually work. When you define a function inside another function, the inner function has access to the outer function's variables. The key points are: first, the inner function maintains a reference to its outer scope; second, this reference persists even after the outer function returns; and third, this allows for data encapsulation and private variables. Let's look at a basic closure example. Here on your screen, we have a function called outer that contains a variable called outerVar. Inside outer, we define another function called inner. Inner has access to outerVar even though outer has already returned. When we call myClosure, it logs "I am outside," because it remembers the lexical environment where it was created. Here's another example with parameters. We have a function called createGreeting that takes a greeting parameter. It returns another function that takes a name parameter. When we call createGreeting with hello, it returns a function that remembers the greeting. So when we call sayHello with Alice, it combines both parameters to create the greeting. Here's an important example to watch out for. We have a function that creates 3 buttons. Each button should log its index. But because of how closures work, all buttons end up logging 4 instead of 1, 2, and 3. This is a common mistake when using var in loops. Here's the fixed version. By using let instead of var, we create a new lexical environment for each iteration. Now when we call fixed buttons, 0, it correctly logs 1 because each closure remembers its own value of I. Closures are great for creating private variables. Here we have a counter function that returns an object with 2 methods. The count variable is private because it's only accessible through the returned methods. When we call increment and then getCount, it correctly returns 1. Here's a more advanced example using the module pattern. We have a calculator that maintains a private result variable. The add and subtract methods modify this private variable, and getResult returns the current value. This pattern is commonly used in JavaScript applications. Let's see a real-world example. Imagine an e-commerce site where each Add to Cart button needs to track its own quantity. Closures allow each button to maintain its own state independently, even though they're created from the same function. Another practical use is with event handlers. When you have multiple buttons that need to perform different actions, closures help each button remember its specific configuration, even when they're created in a loop. Let's compare closures to global variables. Global variables are accessible everywhere in your code, but they can lead to naming conflicts and make it harder to track dependencies. Closures, on the other hand, encapsulate their state, avoid naming conflicts, and make dependencies clearer. Another comparison is between closures and classes. Closures are lightweight and work well for simple state management, especially in a functional programming style. Classes provide more structure and are better suited for complex applications following object-oriented principles. Here's a common mistake to watch out for. If you forget to return the inner function from the outer function, you won't be able to create a closure. The fixed version properly returns the add function, allowing you to create closures that remember the value of x. Another common mistake is using var in loops. Because var is function scoped, all the set timeout callbacks end up sharing the same variable. Using let instead creates a new lexical environment for each iteration, so each callback gets its own value of I. Here's a pro tip. When working with loops and closures, always use let instead of var. This ensures each iteration gets its own lexical environment, preventing the common pitfalls we just saw. Another tip is to document your closures. Since closures can be a bit abstract, adding comments explaining what each closure is doing can make your code much more maintainable. For larger applications, consider using the module pattern we saw earlier. It helps organize your code and makes it easier to manage state using closures. That's it for our deep dive into closures. To summarize, closures combine a function with its lexical environment, remember variables from their outer scope, and are useful for data encapsulation. Just remember to watch out for common pitfalls like forgetting to return functions and using var in loops. If you found this tutorial helpful, please like and subscribe for more JavaScript content. Thanks for watching.